All right. Welcome everyone. Hope your week's going well so far. I know some of you are still finishing up assignment 3. That's totally fine. Not a problem at all. It's definitely a tricky one, so I understand if you struggle with it a little bit. And I will continue to be flexible with the due dates of things. However, I did kind of want to peek ahead a little bit since spring break is only like 2-ish weeks. We have 2 more weeks after this one till spring break. And that's when the class is going to shift quite a bit. We're going to start doing the projects. So I did want to make everybody aware that of a couple things. One, I'm going to try to catch up on all the grading that I am currently behind on. Hopefully by the end of the week or so. I'm hoping to have everything graded that's been submitted to me. So if you've been waiting on stuff, you'll be hearing back from me soon. And then 2, I definitely would like to make sure all the homework assignments are resolved before we get into the project, which basically means, let's get everything submitted by the time we get back from spring break. I'm not going to really want to talk about these homework assignments anymore. I've just had a couple people ask me how flexible I am, and I am generally flexible, but there is going to be a big shift, and I want to have all of these done by then. So just be aware of that. That's basically it. That's all the announcements that I had for today. I know some people have already started on the unit testing assignment, which is great. Let me know if you have any questions on that one. I'll be around later on this week as well. If you want to set up an appointment, come in and work through some of them together in my office or something like that, that would be a totally fine thing to do. But today we're going to return to our conversation about clean coding. So writing code that is not just functional, but is actually easy to read, easy to understand, and hopefully easier to modify, change, take care of, etc. And so last time we talked about names. Today's topic is going to be functions or methods. There is actually a difference between those two, but they are also very, very, very similar. So we're going to talk about them basically the same way today. And there's a branch that exists on the naming repository that I was using last time called functions. I believe it just kind of has a completed version of the naming one, so that we can just kind of all start from a fresh copy. If you weren't able to follow along last class, or you weren't here last time for whatever reason and you want to catch up to where we are now, you should be able to, if you've already cloned the repository, check out that functions branch. And oops, okay, so this is actually not a terrible thing to see. It's telling me that the content of the functions branch is different than the changes that I made to the file last time in class. So it's making sure that I commit these changes before I switch, which is not a bad thing. So let's go ahead and do that. Honestly, I probably should have committed, before leaving class last time, but I didn't. So naming updates. Oh, I need to add the file first. Gosh, I am just making all the mistakes this morning. That's okay. Good review. Source naming dice.java. There we go. I'll just... Alright. I'm not really interested in pushing those changes. The only thing that we need to do to satisfy Git so that we can switch branches is the commit. And if you think about why that is, right, it just needs to know where to come back to when we switch back to the master branch. So it just wants to make sure that everything has been committed, that it's taken a snapshot before we switch over to a different branch. So let's try that checkout command again now, hopefully. Functions. All right, great. And it spits out some information talking about the branch. It says it's set up to track remote branch functions from origin. What that means, remember, origin is github.com. So it's basically saying that we synced this branch up with the one that exists on github.com. And if we switch over to Eclipse and open that file again, that's from 131. That's not for this class. It looks like this is the copy then this is not the same copy that I did last time. This is the copy that was on the branch. The names are slightly different, I think. We need to refresh it, maybe? Actually, I should be able to show you just by switching branches back to the primary one. That, yeah, there we go. Eclipse automatically detects that I switched the branches via the command line. So here's the version that I did in class on Monday. If you weren't here on Monday and you want to pick up where we left off, then you can check out that functions branch. I might actually stay with where we were on Monday, since that's the one that we've been working on. And what we're going to talk about today is methods. So this is actually an old 131 lab. You may have noticed that everything is done in main. That's how we teach people to write stuff at first, right? Is you stick everything in main, and then later on we teach you about this cool thing called methods, which allows us to break code off into sections and then reuse those sections. And we ask people to write methods to do various things, but it can be hard to know when looking at a chunk of code like this, for example. Where should the methods go? Obviously, I think we don't want to stick everything in one big giant method. That's not great. But how do we break this up? What are some ideas? What are some rules we can use to help decide whether a method needs to be broken up or not? So I'm going to talk about a few general rules today and kind of dissect. Yeah, question.
Were you in the master branch? Or?
I am in the master branch. This is the copy just like I used from Monday. They're both the same code. The only thing is just the variable names. I chose, different variable names on Monday than what I did. In the branch. So yeah, some things to look at when analyzing methods to determine if there's some work to be done here to clean them up. Some good general rules to keep in mind. Methods should perform one action, just one action. So if you can look at a method and describe multiple things that are occurring in English, then that method is doing more than one thing. And all of those things that are named are actually kind of the methods that should be now the goal to be written. But to give some more concrete guidelines, some more concrete rules of thumb, this is the first of multiple times I'll introduce you to this idea of the rule of 20, which says that there is absolutely no reason for any method to ever be longer than 20 lines, period. Never. It should just never happen. If you are finding yourself writing a method that is longer than 20 lines, then figure out how to break it up. It should not be necessary. And so this one already, I think, while 20 lines does not seem like a whole lot of code, right? This method just barely gets over 20 lines. It's not that big. But I think the goal is to keep methods short. Very, very, very short. As short as possible. We're not aiming for 20 lines. We're actually aiming for less if we can. Other things to keep in mind, other things to look for. The levels of indentation can kind of help you gauge whether a method is too big or not. There's no limit on what the computer will let you do, right? I'm sure some of us have probably written some stuff that goes trailing off the side of the screen. I mean, that's obviously a red flag. If the code is so big that it doesn't fit on the screen, then that's probably a cue to write a method. But if we want to put it, in more concrete terms, methods should have at most 2 levels of indentation. So you could have a nested for loop in a method. I think that's reasonable, right? But what if that nested for loop needs to contain an if statement? That would be 3 layers. Now, hopefully I'm going to try and train your brains to start thinking about, well, where's the method that we can extract out of this? There's some other rules that I'll point to along the way, but I think we should try and start looking for methods in this code and extracting them out. So I think it's good to get practice for that. One thing that I always like to do if I'm trying to clean up a big gnarly piece of code is to actually start with what I was just talking about, the indentation levels. Go to one of the deeper indentation levels and see, just highlight the for loop or even the if statement, or maybe this for loop, right? this one here, I think I could apply a name to. Can I look at this code and give it a concise English name? I am checking for Yahtzees. That's what this code does. This code checks to see if there's a Yahtzee, right? I know it's been a couple days since we looked at this code, but this is a dice simulation. We're just rolling dice. Very early intro comp sci concepts here. Nothing too crazy yet. But yeah, we could definitely describe this as just a way of checking for Yahtzees, and this is very deserving of a method. In fact, I've even told you what the method name is, or gotten pretty close to what the method name should be. So one way we can do this is, of course, by writing it ourselves and coming down here and, I'm starting with a static method today, which we're going to definitely have a conversation about static versus non-static. It is something that we do cover in 131, but it's always good to have a refresher about this concept because people get confused about it all the time. Today we're going to stick with static methods. When we get to objects on Monday, that's our next topic. We'll have that conversation about static versus non-static methods and when we should use them and when we shouldn't use them. All right, so checking for Yahtzees. What should the input parameters be? This is where it gets a little bit tricky, right? Because what I want to do is take this code and drop it here, but this method doesn't have access to all of these things, correct? The method doesn't have access to those things, so if I want the method to have access to this array and this variable, which do we actually need this variable in here? I think what we could maybe do is, use the return value to help us out here. Maybe just have a Boolean. Yeah, but it's getting a little complicated. I'm actually getting ready to start. Well, let me focus on the parameters. The dice parameter is an easy one to get in there, just by passing in an integer. So is the roll tracker, which is an int array. We're actually counting the number of Yahtzees, which if we allow that to happen up here instead of down here, that would eliminate the need for this variable. So I think maybe what I'm suggesting is, let's look for the case where it's not a Yahtzee and return false. Use our method return values to help us out. If we get all the way through that for loop and they all match up, then it must be true. We're still not quite done yet. We have this pesky value of I here, which stands for the current throw number that we're on. So I is from the for loop. I represents our current throw number. In fact, I would go so far as to call it that as a parameter. Okay. And now, after doing all of that work, what we can now finally do, and I will go back through everything again because I know I probably went through this pretty quickly for some people. What we've effectively allowed ourselves to do is eliminate this chunk of code and replace it with a method call. Although I suppose we also need an if statement or a ternary to deal with this as well. Dice, roll frequency, table, I. What are you upset about? Oh, it's roll tracker. Sorry, I plugged in the wrong array. There we go. Okay. Let me just recap what happened here. Since I tweaked this code quite a bit, after I moved the chunk down to the method that I wanted to make, I had to plug in, any of the missing variables via parameters. And then maybe one of the more tricky things that I did, more complicated things that I did, is I actually rewrote this method a little bit to work slightly differently to return a Boolean value. If this was a proper project that used test-driven policies, this would become a bigger problem because any unit tests that were written for this code would then affect if I change the return value. But since we're extracting this new method out, I suppose it would then also be our responsibility to write those unit tests, which I'm not going to do today for the sake of time. Maybe in a future class we can come back and do something like that. And at this point, I imagine there's probably some people out there who are probably like, wow, this seems pretty complicated, like a difficult thing to do. It is. It's not an easy thing to do. It is going to take some practice. However, there are some tools that I can introduce you to that will help us. Let's do this again. This time, let's try and identify another section, maybe like this one. Can I describe this as a phrase? This is actually like doing a throw, right? Doing a roll of the dice. Doing a roll of the dice. Okay. Instead of going through that whole process again, which I could do, I could very well do, we have an IDE to help us. So I've highlighted this for loop and I've decided, well actually maybe I need to include some of this stuff up above it as well. I don't know. We'll figure that out in just a second. I'm going to right click it and go down to the refactor. And there is a nice handy one here called extract method. That's exactly what we're trying to do. We're trying to extract a method out of this. This one is going to actually roll the dice. It's going to do one throw of the dice. So we click on this guy. It says, all right, here's what we've detected the variables need to be. If you want to, you can change the name of any variables. And I actually do want to change the name of a variable. This one I would prefer to call, throw number or something like that instead of I, to make it more descriptive. The reason being it's a parameter of a method, right? Having I as the name of having I as the name of a loop variable is fine, but having I as the name of a parameter of a method is less than ideal. Let's get into something that's a bit more descriptive about what it is. We have to name the method, so the computer is definitely not smart enough to know what this is supposed to represent in human terms. We have to say that. So what is this? This is roll some dice. I don't know. That's what it's doing. It's a verb. Roll some dice. That's a verb. Or you could get the word some out of there, I suppose, and just say roll dice. Okay. Once I've made those decisions, we can let it do its thing, and you'll see that it has already replaced that big chunk of code with a method call. And we can scroll down and see the method that it generated, right? It's right down here. It basically did what we did the prior step. Extracted all of that code out from up above and moved down here. So that was, I think, hopefully a bit more straightforward. Well, I mean, I would definitely think that it's more straightforward than the way that we had to do it ourselves. Although it's not always going to do, I mean, this is a pretty good job, right? It's not always going to do this good of a job. Sometimes it's going to do things that you don't necessarily agree with, and you are going to have to go back and fix that. it look the right way. There are still some problems that I have with these methods too. And unfortunately for us, we're not going to fix these problems today. We're going to have that conversation about objects first before we do that. But the number of parameters of a method, that's another rule of thumb to keep in mind. I'm sure, like myself, you've written some methods that have very long lists of parameters, but in practice, 3 is the max. 3 is the max that I would expect to see. So we're pushing the limits already, and honestly, when I see 3 methods, I'm trying to think about how to get it down to 2 or even 1. One of the big tools that you can use to reduce the number of parameters is to introduce more objects. There's definitely a need for more objects here. So I know I keep repeating that story over and over and over again. We're going to talk about objects. It's going to happen, sort of ignoring the fact that objects exist for now, potentially. But it'll be very satisfying to come back and insert some objects into this code and see how much we can use that to reduce the number of parameters for these methods and clean it up even further. For now, though, I would like to, spend as much effort and time just getting some practice writing these or extracting these methods out and see just how much we can clean up this code, because we're not done yet, right? This main method is definitely smaller than when we started, but it's still pushing the size. Well, it's down to 15. That's pretty good. Can we do even more? I mean, let's look at our indentation levels and see. This one is going to be doing the actual throws, right? I think we should give this one a shot as well. So a roll is what I'm calling when you throw all 5 dice or however many dice you're using, and then this is actually repeating that throw a certain number of times. So let's try and extract a method out of this, and now we've got a big problem. Although, is it a problem? I mean, yes, it is a problem, but it's a solvable one, I think, or one that we can at least try to chip away at. This is not acceptable to me. Even today, having this many parameters just doesn't feel right. But I think that maybe if we were to include this code, perhaps, some of these variables in here as well, since they're being used down there too, or maybe even the ones up here, for that matter. That might be too much. You could argue that I'm just I'm being indecisive today. All right, let's include those variables in there and see if that helps us at all. Okay, so I did eliminate 1 just by including those variable declarations there. That's good. What if I include number of throws, number of dice? Ideally, all we want to do is just these 3. So if I include this declaration in there as well, I think I could eliminate that parameter. Alright. This is a big chunk, but I still think it's valuable to do this. There we go, down to 3 parameters. Throw many times. That's what we're doing, right? Throw many times. I'm struggling a little bit with the naming of this one. I've been trying to think about what to call this one. It needs to be a verb. This is accurate. That word many is bothering me for some reason, but maybe it's okay. This stuff is very subjective. Does anybody have any suggestions? Or are you stuck on something?
I had an issue with it.
Oh.
It's giving me like an error. It's like setting ambiguous return value.
Ambiguous return value. So what that means, when it's saying ambiguous return value, I would assume what it means is that it thinks that it needs to return more than one thing. In this case, in my situation, it's returning one thing that I believe is the number of Yahtzees, or yeah, something like that.
Oh, so I forgot the system out.
Forgot the print line? Yeah. What is it returning, actually? I guess we'll have to extract it and find out. This is one that I feel like it's going to be hard to get Eclipse to do it well for us, but let's see what it comes up with and we can tweak it a little bit. Oh, it's returning the frequency table. That's interesting. That's interesting. Okay. This method still feels kind of big to me for some reason, but I'm struggling to think about how to condense this even more than we already have. I mean, it's pretty good. It's pretty good. I think, again, objects is probably part of the reason. One of my main goals, though, since we're talking about methods today, let's talk about our good friend, the main method. Main methods should be very short, always. So the rule of 20 does not even apply here. Main methods should be a few lines tops. So I'm not going to stop working on this. I mean, this is still too much. Having a for loop in a main method is kind of a red flag to me. Like, in 131, sure, yeah, all we know is the main method. Yes, absolutely, it's fine. But we know about how to write methods. We know how to write objects. So having something like this in the main method where I'm printing out stuff, no. I mean, even this, having it as a small method, I don't mind small methods. I can describe what this is. I'm printing out the frequencies, right? I'm printing out all of the frequencies. So one thing we can do is start to extract some even smaller methods out, especially if we can apply a name to them. That's an easy one. And look at what our main method has become. It's actually just become a couple of method calls. I wonder if I could even move this line into throw many times. Why don't? Oh yeah, and then get rid of the parameter. I like that even better. Fewer parameters makes me happy. Cool. So look at how nice and tiny our main method is now. That's wonderful. Declaring a couple variables, calling some methods, that's good. Creating an object and calling a method on that object, that's a good main method. That's really all it should be. I don't want to see if statements in there. I don't want to see for loops in the main method. Ideally, it would be creating an object and calling a method on that object. And that's what it will become on Monday when we start to talk about objects a lot more. I'm still not done. I actually want to keep going and see. I mean, this is a skill that's only going to get better with practice. And I think it's important to see just how much you can squeeze out of this thing. It's also very satisfying. I mean, I find it to be satisfying to clean up code like this. I'm looking at a chunk like this now. Well, we already extracted all this stuff out, though. Is it taking... Oh, it... Well, that's me being a little nitpicky, I suppose, but... No, I guess this is probably about as good as it's going to get, huh? I disagree entirely. Well, not entirely. I disagree with that statement somewhat, that it's as good as it can get. I'm sure somebody else could look at this. Does anybody have any ideas as to where it could extract any more? It's very subjective, so there's not really a wrong answer. I think somebody who's even more grossed out by long methods than I am would say, this method is too long. 13 lines, 15 lines, there's got to be something in here we can extract out, right? Like even just this. What am I doing? I'm computing and printing the sum. Why not? Let's make some really tiny methods. These are just variable declarations. Hard to extract those out. This is 2 levels deep, so my eye is drawn to that. I think I'll leave it be for now. Alright, I'm done. I could stare at this all day and debate whether I should extract any methods out or not, but that would not be an entertaining class to have to sit through. Any questions? Anything that anybody would like me to go back over before we talk about something else? Okay. Then let's chat about a slightly different topic. That's not going to be nearly as, I guess, meaty as methods, but I am going to throw it in for the sake of completeness, which is comments. So I know that a lot of you are familiar with the JavaDoc comments that we make people do in 131, putting these above your methods, right? The idea is that you're supposed to include a description here of what the method is doing. So and then actually here, if it's not clear enough from the parameter itself, you can provide more information about the parameter, but just restating, the frequency table feels redundant, so not always necessary to include that information if you don't feel up to it. But I wanted to show you something that, is an important thing to know about this, about these style of comments. Let me do one more. The given number of dice throws number of times. This is kind of redundant too, I suppose. And it's returning a table of how often each sum was rolled. Like that feels like a very good and useful, necessary description of the return value, right? Especially considering the case that, who are comments for? Who are the comments for? Sometimes they are for you. I don't know how many times this happened to you, where you've had to go back and look at something you did a while ago, and you're just going, I have no idea what I did. If it hasn't happened to you yet, it will. It happens pretty regularly, so comments can be for yourself, but really more often than that, they're for other people, for other programmers, especially if you want them to use code that you've written, code that you've provided to the world to use for their own purposes. So I wanted to show you, right, what actually happens with these JavaDoc comments, why we stress them so much. I guess I should also comment on when they're not necessary. people in 131 get a little overzealous with the Java doc comments. You don't need to put them on getters and setters and methods like that. It's open. It's not necessary. People generally understand how getters and setters work. But for any methods that are doing a major amount of work, they probably should be included. And then what you can do is in Eclipse, you can go up to Project and Generate Java Doc. It's going to ask you which project you wish to generate the Java Doc for, and it's going to ask you where you want to put it. Usually it will suggest just putting it in this documentation folder within the project, which is fine. I don't have a problem with that. Okay, go ahead and save some stuff. Do I want to update the Java doc location? Sure, that sounds fine to me. And then it's doing some stuff. It's doing some things. 3 warnings. Okay. I now have this nice doc folder, and it contains what looks to be, website pages. In fact, is. You've probably seen pages that look something like this before. If you ever Google the official, Java documentation, like Java string or something like that, it's going to look a lot like the official Java API, right? It's that's intentional. That's kind of the idea, because what it has done, if you click on the class and scroll down, you'll see that what that Java doc actually does for us. If I can find... Oh, is it because I think the methods aren't showing up here? Probably because they're private, is my guess. Is it only the public methods that are shown? Let me check that and see. Those are private, yeah, and I think because they're private, they didn't get included. Let me switch it. And then I have to redo the generate Java doc again. That's kind of annoying, but that's my fault. Hopefully this time it will work. There we go. Yeah, this time it did what I was hoping it would do. And notice that it just rips those comments directly from the Java doc. And if you click to go down here, right, here's the description that I gave of the parameters. Here's the description that I gave of the return value. So it just generates basically the API documentation for you, right? Based directly off of the comments that you provide. And then you're free to distribute these out to whoever wants to use your stuff. It's now a description of how to access these methods and use this. It's a very neat tool that I feel like is often overlooked by students, or just people in general, not just students. Yeah. And then the other kind of comments that I wanted to chat with you about today are of course the inline comments. So these guys. Some people, when they're first learning programming, and I actually was guilty of this myself, they'll comment their code pretty thoroughly, right, with what each line is doing in English. Something like this. I think this is actually dangerous, so it feels maybe comforting to do. If you're learning, it's not so bad of an idea, right? If you're studying for an exam or something, it's not so bad of an idea. But if you're a professional programmer who's writing code to be used by other people, this is a bad idea. This is a very bad idea, for reasons that happen to me actually in class all the time. I'll decide that I need to make a change to something for some reason, and then these comments quickly become inaccurate. So as I go in and I change the program and I modify a line, this was true at one point in time, but now, after I've decided to use a list instead of an array, this comment seems a little off. Or maybe the array goes away entirely and I start using objects instead, but the comment remains, right? And then misleading. It's misinformation. It's disinformation. It's not helping people at all. It's making things more confusing. So that's not the goal for comments. The goal for comments is to try and explain stuff that isn't already explainable by the code itself. So what I mean by that, if you're following good practices, naming your variables well, naming your methods well, try and keep things short and simple. Analyzing a method that's 50 lines long is way harder than analyzing a method that's 20 or less, right? In the general case. So keep things short and sweet, keep it simple, focus on one thing, name things well. We're writing code that is easy to understand, hopefully, just from reading the code. And if there really is something that is complicated that you genuinely feel is, the code is not expressing very well, maybe there's a particularly complex algorithm that's involved, then okay, sure, it can be useful to say, this is the part that's doing X algo or something, right? Like, yeah, drop a little note in there that's like, this is the chunk that is doing all the hard work. Maybe even if you have a reference link to it, include that in there as well. Those are good comments. Let people know where the heavy stuff is. Let people know where the complicated stuff is. If you can provide more information about the complicated stuff, then do so. At the very least, this is kind of a glaring, flashing neon sign to not mess with this stuff unless you really know what you're doing, right? If you put a comment in here that says, this is the part that's doing a very important thing, people are going to think twice about messing with the code that does very important things. So you shouldn't be dumping those all over your code, but if you genuinely have very important things, then that's a good use of comments. Yeah. All right. I think that's all I have for comments. What I would like to do for the rest of the time is actually get some more unit test practice because I know that is a new skill and one that I don't think that we can practice enough. If you're bored or feel like I'm beating a dead horse, I'm sorry, but I'm going to ask you to do this on the project. So I think getting good practice is a good thing, and this is one of the trickier skills I feel like to build up in the class. So I had this menu system repository that I posted a link to on the calendar when I first used it during the test-driven development class. So this is the repository that I created and first used to explain unit tests. And for the last 20-30 minutes or so of class, we're going to just crank out some more unit tests and get some more practice doing that. All right. So go ahead and grab this if you want to follow along, or if you still have it loaded up from when we did it in, or actually you wouldn't have had it, well, maybe you did if you checked the calendar after I posted it, I suppose, but yeah, go load it up if you'd like to. Where we left off, we have something that allows us to add items to a menu and then computes the total of those items. And so let's keep going and think about what other kinds of things that we're going to need our mini system to do for us. There are some easy ones involving the price that I can think of, such as computing a tax value. And then if I have a tax value, then I've got, I have to compute the grand total of all the items, maybe including a tip somehow. So how do I want to include, how do I want to include a tip or something like that as part of the bill? So let's start with, I think, tax rate or something like that. And we can, I'm starting in the wrong place. I'm starting in the actual class. I want to emphasize this idea that we're going to do tests first. So I am now in my unit test. Here's all the ones from last time. We can actually, let me refresh my own memory as to what our setup is doing. It's creating a simple order with some items on it that I can use to help me with my tax computations, right? So I'm going to come down here and build one more test. We'll call it compute tax test. Might change that name later, but for now it's fine. What do I need? I need a simple order that I can tell to compute some taxes on it. And then I need to verify that the actual taxes computed are correct. So step one is set up our objects. In this case, I just need an order with an item on it. At least one item on it. Although that just gave me another idea for a test that we might write as well. So we have an order. I'll add one of the pre-existing items that we have. Sure, fries is fine. Step two is to call the method that is being tested, which is, this is where we actually would design our method. So I'm going to call, what do I want to call this method? What parameters do I want this method to have? What return values do I want this method to have? So let's think about this. I think there's an interesting conversation potentially to have about the parameters. Do we insert the tax rate as a parameter? I think most restaurants use the same tax rate for everybody, right? They're not using different tax rates for me or for you. Sometimes people get things tax-free in certain situations, right? But it's not like the tax rate itself is changing very often. So I think there's an argument to be made that we don't input the tax rate here, and it's just set to be some constant value for every single order. I think both situations actually could have their purpose. So if you have a need to change the tax rate often, then you could include it as a parameter, but these are the decisions that we're making now as we're writing the tests. These are the kinds of things that we need to think about and answer now. So let's say we want to use a constant. I'm just going to assume that there's going to be some constant defined maybe in the order that says what the tax rate is. And then once it does that, it should be able to tell me that value, right? Give me that tax value. And then I should be able to do step 3, which is actually I want to reiterate that we can use multiple assertions. We're not limited to just using one. We need to verify multiple things. So something like assert equals, what do I expect the tax to be? Well, that means that we need, do I know what the tax rate is, right? How do I know what the tax rate is? How much tax would there be on, $2.50? Let's assume that the tax rate is something that we can do math with somewhat easily, like 0.1. So the assumed tax would be a quarter. So the way to interpret this, the first value is, what do you expect the amount to be? The second value is the actual value that was returned by the method. So when I say actual value, that is almost always going to be a value that is returned by a method. And then because we're dealing with doubles, remember this last value, I might actually make that a little smaller, is how much wiggle room there is, how much tolerance there is. Doubles are not exact. There's rounding errors involved. So we always have to include a little bit of a tolerance. They can be off by this much, and we'll still consider them to be equal. I'd actually like to write another test before I try to implement this method. Because, you know, while the bare minimum number of tests for each method is 1, you can always have more. And I think usually it's very useful to have more than 1 test. So I was thinking of other situations that we might want to test, right? Such as how much tax there should be on an empty order. This is kind of what I would consider an edge case, right? Can it properly tell me that there's no tax on an empty order? But it's going to use the same kind of setup, same 3 steps anyway. The order starts out empty, so as long as we don't add anything to it, then actually step 1 is accomplished for us due to the before each method up here, so that's kind of nice. For step 2, calling the method, that's still going to be compute tax, right? We're just calling it on an empty order this time. And then for our assertions, the expected value is 0. The tax variable contains the return value from our method call, and we'll use a very small tolerance. I'm trying to think if there's any other ways that we could test this method. I mean, to be fair, I think that, you know, I'm not entirely satisfied by this test to say that it's computing tax correctly, right? I'd want to give it a few different items. In fact, you know, this idea that it can compute tax on multiple items could even be worthy of a test. So let's do one more. I'm going to actually just copy this entire test and make some changes to it. Compute tax multiple items. And then that might also actually cause me to rename this one compute tax single item. Nothing wrong with being very explicit about what I'm trying to test for. Okay, and so I'm just going to add some more stuff this time. We'll add a burger and a soda as well. And the tax for all of that at 10% would be 10.50, 11, 12 and a quarter. So it'd be $1 and 23 cents, give or take. Alright, so that's 3 tests that I've written. We can now go through and talk about implementation, and hopefully at this point it should be straightforward. The idea of implementing this method, we've already discussed how it's supposed to work. We've already decided that there are no parameters. We've already decided that it's going to return a double. We've already made these decisions. So when it comes to writing the actual test itself, it's pretty straightforward. We're going to need some kind of a loop to go through here, right? And apply the tax rate to each and every item. It's actually going to look similar to this, but just with the tax rate involved. So this is a bad idea. What's that called? Anybody remember? The name for what I just did. Well, I already set a couple different answers for what I just did. I hard-coded it, right? Hard-coded it right in. This is also called a magic number. Magic number is any value that is not easy to necessarily determine just by looking at it, I think most people would eventually come to the conclusion that this must be the tax rate. But if that's in fact what it is, then give it the name, right? Call it what it is. It's the tax rate. Furthermore, a value this important, I think, is deserving of being made a constant. And so constants can be made, well, I mean, constants don't have to be public, they can be private. Probably going to be final. What does final mean? Does anybody know? We used to cover this in intro, but I don't think we do anymore, actually. Something is declared as final. That means that this variable can only be set one time. So I can assign a value to this variable once. I can't use it on the left-hand side of an equal sign ever again after that. It'll cause an error in my code. So if I have something that is truly important, like a constant, right? Marking it final is a safety thing. It's a protection so that you don't come and screw up that value later on in the code, perhaps unintentionally. It is going to be a double rather, not an int. And then constants do also, by convention, have all caps names with underscores for the spaces. I should probably put this in the class instead of outside of the class. That would help. Maybe on this, yeah, this spot right here. And then I also forgot to set it to be the value that I want it to be. Keeping it up at the top also makes it very easy to find this value and change it if that becomes necessary. Tax rates do change, right? So by doing this, I now can see it right up there at the top, and if the government does change taxes for whatever reason, I don't have to go digging through all the different spots in the code where it's hard coded 10% of the tax rate. Just got it right here, right at the very top, and then I can come down to where I had this hard coded before and replace that with the constant. The nice thing about using all caps and underscores, using a different convention, is that now when you look at this, your brain is hoping you think, oh, that's a constant. I can't mess with that. I can use it, but I can't mess with it. It's a constant. Great, and I think we've actually finished the method, so we have to do the last step of our test-driven development, which is to make sure our tests actually pass. So let's go ahead and run these as unit tests. Awesome. Now, ideally, they do all pass the first time like this. That won't always be the case, especially if you're writing code that's more complicated. Although, also, one thing that I think is important to note, look at the method that was generated by test-driven development, right? There's not a lot of extra refactoring work that needs to happen here. It's already pretty good. It's already, I think you could argue maybe some of the names aren't super great. Like MI is not a great name for menu item, but okay. Other than some small little nitpicky things, it's not giant method. Using test-driven development actually does lead to smaller methods getting created because big methods are hard to test. Very hard to test. So if your goal is to pass tests, which it generally is, that's how we verify our code is working properly, small methods are going to be much easier working towards that goal. I want to show you one more example of a test that might use multiple assertions and when that might be a necessary task for you to kind of wrap things up for today. So let me go make one more unit test over here. We're going to do one more method for the grand total. So actually, I think we might have a little bit of refactoring to do. And I want to do that real quick here. This says compute total. I don't think that's really true anymore, right? This is just computing what I would call the subtotal. It's the total of all the items, right? But that's not really accurate anymore. In fact, we can rename this by refactoring it. And the nice thing about doing that is that it will go and find it. I actually didn't go and find it in this file. It broke the, no it did. It did find it. Why are you angry at me then? Oh, okay. Just had to save the, okay. It went and found where it was using the unit test and changed the name there as well. It's a very handy way of letting Eclipse do some of the hard lifting for you. So you don't have to go track down all of these unit tests. I mean, if you want to be extra sure, you can still, run the unit tests and make sure they still pass, which they do. I actually think I made another mistake when I was implementing, well, not mistake necessarily, but less than ideal situation. Like, now that I've conceptualized this as the subtotal, computing the tax is actually even easier than this. I'm doing too much work here. I should just return compute subtotal times tax rate, right? There's no need for me to loop through all those items again. Got a method that does that already. And after this refactoring, I would again run the tests, make sure they still pass. Oh good, they do. Fantastic. I've just made this method even simpler. I love that. That's always a good thing. That makes me feel good. Gives me a nice little dopamine rush, making code look nicer. All right. So for our last method, then we'll do one that covers the grand total. So the grand total would be the subtotal plus the tax, right? That would be the total amount for the entire order. And same 3 steps as before. We need to have, something, an order with some stuff in it. I'll go ahead and, whoa, what happened there? I didn't mean to do that. I'll go ahead and add everything to the order. The method that I want to call this time is, well, it doesn't exist yet, right? But it's about to. Compute grand total. Does it need any parameters? I'm not so sure that it does. Does it have a return value? I told you what I think about that just by expressing that there's a variable to store that return value, which I expect to be the total. And then for the assertions, I think there's a few ways that we can assert. Of course, we can tell it that we expect this to be whatever the grand total is going to be, $1.23 plus $12.25 would be $13.48. So that's what we expect the bill to be. With some degree of wiggle room. But also, there are other things that I would expect. Such as, if I were to grab the tax and the subtotal, I would expect those two things put together to also be $13.48, correct? Or another way of saying that is that I would expect the total to be equal to the tax plus the subtotal. And this might seem like it's redundant for me to say, aren't I kind of saying the same thing that I said in that same assertion? But think about what these two assertions are actually doing. This one's going to just be a red flag if the total's off for any reason. But here, if this assertion goes off and tells me that it has failed, then I know it's due to, there's some problem with one of these component parts, right? Especially if I know that the code is going to get changed, just like I just did when I came in here and refactored. Having multiple assertions, having multiple ways for code to fail, it's going to give us more information. It's hopefully going to make it easier for us to diagnose the problem when those failures do occur, so that we can fix them faster, more effectively. And so yeah, I would also consider, writing more tests for the grand total. I think it would be useful to test for an empty order, just like we did as well, but I'm not going to do that right now, mostly for the sake of time. I'm just going to wrap things up by hopefully implementing this method, which should be fairly simple if we think about how we get that grand total. It's just the sum of these two things, so we can rely on those methods to help us. I won't make the same mistake twice. And oh, I forgot did I forget the annotation? I always forget. No, I didn't forget the annotation. Oh, it's just up here. I was looking for it at the bottom, but it wasn't there. Oh, I see what happened. Well, I'm a little upset that I switched naming conventions here. That's my bad. Should try and be consistent with that, shouldn't I? Anyhow, I'm gonna fix this up and commit it. And I mean, anytime that we have a chance to write more unit tests and do more clean coding stuff, I think it's just good practice. These are skills that need practice in order to be developed. Does anybody have any questions about what we've done? I'll commit and push this, so if you want to take a peek at what we've done after class, I'll do the same thing with the naming stuff, the method stuff, and then just as a one final reminder, we're going to be talking about objects on Monday. That'll be our last sort of clean coding topic before we switch to talking more and more about the upcoming project. Alrighty, I'm going to end it there. I know some people are still working on homework assignments and stuff, so if you want to come chat to me about those, I'll be happy to stick around, help with homework for a while. Otherwise, I hope the rest of your week goes well. I'll see you back here on Monday. Thanks, everyone.
Could you go back to the order.download?
Of course.